Hey everybody, this is Larry. This is day 27 of the Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this poem. And apparently I haven't done before, so yay, let's do something fun. Or something like that. Yeah, hope everyone's having a great weekend. When do we swing forward? I feel like the time something. I don't know. But in any case, hope everyone's having a good week coming up. And let's get started on today's poem. Today's problem is 427. Construct quad trees. Tree. Given an n by n matrix of zeros and ones, we want to represent the grid of a quad tree. Return the root of a quad tree representing the grid. Notice that you can assign the value of a node to true or false when its leaf is false, and both are accepted in the answer. Okay. I mean, I kind of know what a quad tree is, so that's why I thought I've done this before, but maybe not on Leetcode. Or is either that or maybe there's like a construct a quad tree 2 that I've done instead of this one. But yeah, let's take a look. So you have a grid of n by n, and basically the idea behind a quad tree, and we'll see if it's like divisible by divisible by 2 or something like this, because basically the idea behind a quad tree is kind of almost the same idea as a regular binary tree that goes only left and right. You could, the way that I want to think about it, it's kind of like divide and conquer, right? Actually, they actually have an image here, but the idea here is that where a binary tree, or if you think about like a binary tree representing, say, a 1D array, then something like that. You could do it by half, and then half the array would be, and then you kind of compress it that way. In a way, the goal of this is to, a couple of things maybe. Wait, let's see. Okay. Yeah. So, because there are a couple of ways you can think about it depending on the implementation or the specification. But the idea is that you can kind of think about it as a rudimentary compression scheme, right? Where if all the zeros are together, then we can just eliminate the leaves, right? And then kind of divide and conquer. And that's the part of conquering. So let's get started. I don't think there's anything that that tricky about it, or rather, I think that the implementation will kind of make the divide and conquer clear. So yeah, let's get to it. Also, if you're watching now, I am going to do a bonus Leetcode poem afterwards. Today, I guess I felt I feel a little bit better. I don't know. So yeah, so we'll definitely do that. So definitely hit the subscribe button, wait for that video, and let me know what you think, because I feel like, I don't know. If people don't like it, then I don't do it anymore, right? That's the end of the day, right? Or even if people like it, but they don't watch it, then, what's the point, right? Okay, so yeah. So basically, we can maybe do something like, construct is over here. Construct helper, maybe? I don't know. Right? And basically now, the way that I always think about these things, like I kind of already did, is by doing the 1D version and then just kind of like sprinkle in an extra dimension, right? So here, maybe if we think about, a 1D array, we would have the left bound and the right bound, and then when you divide and conquer, you just take the middle and then, separate it out that way. In here, we'll do the same thing, except for now, we have, so upper left and the bottom right kind of defines a square, and from that square we can kind of construct it. You can also do it in other ways with kind of with like some sort of numbering system that's a base 4 probably. You can probably construct it that way, similar to how you would think about a binary tree. You have 0, 2x plus 1, 0, 2x plus 2, or something like this, right? On each of the nodes. You can kind of think about it that way and maybe do it, that way with quad tree as well. I'm not going to do that, but I'm giving you some ideas in case you wanted to. So yeah, so let's just say we have left, right, top, bottom, right? Oops. Yeah, and you can even maybe think of these as like 8x, maybe this is a little bit cleaner. You know, ax ay or something like this, and then bx by or something. Same thing, really, right? So then now here, if left is equal to top, then we assume that, you know, right is equal to. Oh wait, that doesn't make sense. Hang on, sorry, whoops. If left is equal to right, then top is equal to bottom because we're always divided by 2 anyway, right? On each of those dimensions. So that means that this has one element. And then basically now we want to return a new node of, that's weird. What's top left? Oh, that's the nodes. Okay, sorry, I got a little confused. I was like, what is this? But yeah, basically the value will be grid of left top. As we said, this is they're all going to be equal to each other, right? Left is equal to right, top is equal to bottom. So this is just one node, right? We have is leaf, so this is going to be a leaf, and then none. I think, yeah. Otherwise, what do we do, right? Well, now we just try to figure out the mid in both ways. I'm a little bit have to be a little bit careful about this one, just because I'm really bad about it. But plus, I think this is good, but it may be off by 1, something like that, right? So mid x is equal to this, mid y is equal to top plus, right? And the way that I always like to think about it is I use real numbers because to handle the off by 1s, right? Meaning that and these are always going to be powers of 2-ish. Or off, so let's say 0 to 15, right? Then the half is going to be 7, so you want that 0, 7, and then 8 to 15, both of which will contain 8 elements, right? So that means that we want this mid to be part of the left. So then you have a construct helper left to top, mid x, mid y, and now this is just about, well, going through the cases, right? So yeah, so let's just say, so this is going to be top left, maybe I got that, right? Top right is going to be the same thing, except for now it's going to be mid x plus 1, and then this is going to go to the right, right? Yeah, okay. Yeah, just want to make sure. And the way that I didn't make this explicit, but now I will, right? This is all coordinates inclusive. You don't have to do it inclusively. That's just the way that I do it, because I don't know. You can definitely play around with the other way. But yeah, bottom left is going to be mid y plus 1. Oh wait, whoops. From the left, mid y plus 1. It's going to go to the right. No. It's going to go to mid x, and then it's going to go to the. This is wrong. Oh yeah, no, this is right. Bottom, yeah. Yeah. Okay, and then bottom right is equal to the same thing, kind of, but mid x plus 1, mid y plus 1, right, and then bottom, right. Okay, so then now if top left dot, so now if all the values are together, then we merge them, right? So that's basically what we want to do here. Then we just return a new super node of, you know, this, and then now it's going to be is leaf, or is leaf is going to be true because now it's a new leaf. Oh wait, I have to check something, don't I? Do I have to check that they're all leaves? Yeah, I guess we should check that they're all leaves. Okay. Yeah. Okay, then now we just, you know, the value is going to be all the same as we know. This is now a new leaf, and then yeah, we don't have any leaves. Otherwise we just return a node of I guess the values don't matter, right? That's what they say. To true or false when. Oh wait, is value true or false? Is that what it is? Maybe I'm. No, it's just 1 and 0. This is very weird. They sometimes use true and false, and then sometimes they use 0 and 1s in the thing. So I'm getting a little confused. But either way, it's the same thing, right? So here it doesn't really matter. But by notation of us, we just keep a thing, and then you just top left, top right, bottom left, bottom right, right? And that should be good. So now we do construct helper from 0 to n-1, 0. Oh wait, no. 0, 0 to n-1, n-1. And I think this should be good. Hopefully. If not, then, we have to debug. Isn't that the syntax? I think I needed a thingy here for... Okay. Well, that's awkward. It's also like very poor, like this visualization kind of means nothing to me, to be honest. So that's why it's a little bit weird. And I guess this what is it printing? Like, tell me, what is it printing? Is it the value and then is leaf or something? No, it's is leaf and then the node value, I guess. Because this is telling me it's wrong, but then I have no idea how to look at this, right? Is it not merging correctly? I think maybe I have to add a parens. Maybe some of this was a little bit weird. I don't know the order of operation, but okay, at least that's fixed. Did I do the math one? Alright, so this claims that this, but really, I think all these don't really. Maybe it does. It's hard to tell what is actually wrong. Okay, let's see. Do I have an off by 1 maybe? This is the bottom, and it goes to the bottom. Left goes to mid X, and then mid Y goes to the bottom. This, oh what? No, this looks okay. I want to say. Unless I'm doing an off by 1 somewhere, but what is going on? Seems like I have I merged a node that I shouldn't have, maybe. Besides that, I didn't really leave it. Okay, let's look at, oh yeah, this is one example, so we should be able to see. Okay. Oh, I see. So 0, 1, the value doesn't matter because it's not, yeah, so this one doesn't matter. It's a little bit deceptive. 1, 1, 0. Is this wrong? And this is really hard to tell how to debug, because I don't know what's wrong with the, or like, it's definitely not, it should be a 0. Did I do the order wrong? Top left, top right, top left, top right, right? Top right, yeah, bottom left, bottom right. Seems like I'm doing it right. Yeah, I mean, unless I mixed them. I think that was the only thing, maybe. But, why would I think bottom left? Oh, I see. I think I mixed up my X's and Y's. My coordinates are flipped. Maybe. Is that true or am I lying to you? I think that's true. I think that's probably why. Alright, let's see. How do I fix that? Because I use my left as X, that's why. Okay. So then we just have to do this, I think. Maybe. Oh, I mean, now we have to change other things too, I think. Alright. I think I just confused my X and Y's, because I think my left and right should be Y's, right? So let's actually just go through that way. So, okay. Let's fix this. And then now this means that this is Y and this is X. Okay. I think that's Y. Okay, and I think that's only. I did confuse myself. Okay, well that did not fix it, unfortunately. But at least we can maybe look up 1 is leave. No, then X to the bottom, Y1 to the bottom right. Okay. Okay, I think that I think this at least makes more sense. Now, it is kind of embarrassing. I don't think this is that hard, but I'm just struggling with just kind of making sense of what this data is, really, to be honest. But because this only has 3. Because, okay, so this is the root, that's things. And then I don't know what all these all these nodes mean, because it doesn't match 4 of these, right? This is just such a terrible visualization scheme. But is there any way to show this? No? Okay, fine. Alright, I think maybe it's time I give up on the thing and then just and then maybe, like, you know. Okay, so what I did was that I was trying to create a very simple case where I didn't have that symmetry, so it would have to give me something wrong. So I guess, I mean, this one doesn't matter, right, they say. So it goes top left, top right, right? Top left, top right, is that it? Yeah, there should still be top. Top left is 1, top right. Huh. So mid Y it is going to be, so it goes to 0, 1. Yeah, 0 to 1 inclusive. So this is going to. Did I mess something up here? Oh, I see. Because that's the thing that I didn't fix, because I got the wrong thing. Okay, silly Larry. I fixed most of the other things, but yeah, it was just mixing up X and Y's. That's the part where, and then I fixed in all these code except for I forgot about the base case. That's why, because I was looking up the wrong cell. Right. Well, what is the complexity here, right? I mean, it's going to be linear time. You look at each cell once. There are. Is that true? Yeah, I mean, maybe you can say there's a log base 4 component. No, it gets, each one gets merged log base 4 times, I guess. Yeah, so I guess this is kind of. No, because at worst it is going to be linear, because each cell. Okay, yeah. So this is linear time, linear space. The way that I think about it, even though it is a little bit complex, is the same as the binary tree, right? So even though there are log n levels, log base 2n levels, but actually the summation is something like n on the lowest thing plus n over 2 plus n over 4 plus n over 8 plus ... right, amount of work. And of course that sums to 2n, and that is going to be all of n, right? And in this case, it's going to be n plus n over 4 plus n over 16, which is not even going to be 2n. I don't think so. I actually don't know what it converges to, but it'll be, is that true? Yeah, I don't know, but I imagine it's whatever, right? My math today is really bad. I mean, those of you who know it's convergent series know that this converges, but it's going to converge less than 2 times n, I think. But yeah, still O of n in either case is my point. So yeah, linear time, linear space, and that's all I have with this one. Let me know what you think. Hope you didn't make that silly mistake like I did. But yeah, stay good, stay healthy, take good mental health. I'll see y'all later and take care. Bye-bye.